Welcome to the Aspire demonstration movie. This one will focus on ADSS Lite, a tool for security modeling and security assessment of software protection. In Aspire, we use Petri nets for attack modeling. Petri nets model different tasks to perform an attack. The transition in the Petri net, which are the black rectangles, represent the attack steps, the task that the attacker has to perform in order to achieve a final goal. Final goal is one of the states of the Petri net, which are the white circles. Petri net has a starting state, a final state, and different intermediate states. The final goal can be achieved by different attack paths. Attack path is a sequence of attack steps. For example, T0, T1, T3, T4, T6, T8 is an attack path that the attacker can use to achieve the final goal. Another attacker might have a different strategy, performing the attack step T0, followed by T2, then T3. Then at P3, there is a decision point in which the attacker may want to decide to perform the attack step T7, and then in the attack with the attack step T8. The ADSS Lite architecture contains two main components, Petri net editor and the software protection assessment component. This one contains the protection fitness function and the Petri net simulator. The users of the ADSS Lite can start editing the Petri nets and store them in the Aspire knowledge base. The Aspire knowledge base is part of the Aspire Decision Support System, the ADSS Full. The ADSS Full can provide different protection solutions. Each protection solution corresponds to a configuration file for the ACDC, the Aspire toolchain developed by the Aspire Consortium. The ACDC builds the protection solution given its configuration file and generates two files, one with the annotation of the code regions protected in the binary code, and a file containing the binary code matrix. The matrix framework developed by Ghent University is described in detail in another Aspire video. Similarly, the ADSS Full, developed by Polytechnic of Turin, is described in more detail in another Aspire video. The protection fitness function at this point can use the metric files and the configuration information inserted by the user to the editor to calculate the protection fitness. This process can be executed many times for different protection solutions, and then the different protection fitness can be used to rank the protection solution and find the best one. Let's see now how the tool works. The ADSS Lite is implemented as a set of Eclipse plugins. The main components of the ADSS Lite are the Petri net editor and the software protection assessment here below. The Petri net editor has been built by extending the EPNK open source tool from Denmark Technical University. As you can see, we have built Petri net which contains different transitions, which represent different steps in one of the Aspire use cases. Here we have in P7 a decision point in which the attacker can choose to execute transition 12 in order to reach the final goal P8. Otherwise, you can go to transition T8 or can perform T9 or T10 followed by T11 in order to reach the final goal P8. The attack is successful. Each attack step, T1, T2, T3, and so on, is associated with a formula representing the set of metrics from the ACTC metrics framework associated to this particular attack step. For example, T6 is associated with the static program size and the cyclomatic complexity calculated by the metrics framework. In order to start the assessment, first we need to load the Aspire knowledge base that will contain a set of protection solutions pre-calculated that are visualized here. Then we can also load the annotation files generated by the Aspire toolchain. We can also associate the single code region represented by the annotation to a particular attack step. Once the annotations has been loaded, here all the code regions associated with these annotations are visualized. Is it possible to get a fine-grained assessment to associate a set of code regions to each attack step? For example, I may associate to the attack step T5 these two particular annotations. Alternatively, I can choose another attack step and associate another set of code regions identified by these annotations, A2, A3, A5. Here, there are the different protection solutions fetched from the Aspire knowledge base. You can select one, load the metrics, and run the assessment. You see the protection fitness calculated here for this particular solution, and the corresponding attack path, which is the minimum path for the attacker in order to achieve the final goal. Minimum means that, according to the metrics defined in the model, path going to T8 is the one requiring less effort to the attacker. You can run another solution and run the assessment. And then another solution. And then another one. We can run the protection solutions according to the protection fitness function. And we see that currently this solution is the best we have found so far. The Aspire project has received funding from the European Union 7th Framework Programme under the Grant Agreement number 609734.